Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, do you want a cookie? Very good. Welcome to Algebra. This is stream 3 of the absolute value function and its transformations. So if you haven't watched stream 1 or 2, I would highly recommend watching those if you're watching this recording right now. I went through a lot more of the introductory explanations that I'm going to do today. I really want to make sure that we get into solving absolute value equations. So I'm going to jump ahead a little bit. So if you haven't watched stream 1 or 2, then make sure you check those out. Remember that the absolute value is the distance from 0 on a number line. So for practical reasons, it just turns everything positive, but that's the reason why it turns everything positive. For the same reason that we have to consider the positive or the negative result of an equation when we take the square root. For the same reason, we have to consider the positive and the negative result for the absolute value function. For example, notice that there's a mathematical phenomena with negative numbers and squaring. Negative 3 squared, quantity squared, is positive 9. Positive 3 quantity squared is also positive 9. So when we do the opposite operation to solve, when we take the square root, which is the opposite of squaring, we have to consider the positive and the negative because both negative 3 and positive 3 squared will produce those outputs. The same thing is true for the absolute value function. The absolute value of negative 3 is positive 3. The absolute value of positive 3 is also positive 3. So when we're solving an equation that has absolute value bars in it, in order to remove the absolute value bars, we have to consider the positive and the negative outputs of the equation. And we're going to get into that in a lot more detail in a few seconds, but that's my summary introduction. Let me go ahead and share my screen with you. And just a reminder, these are live streams, so there's a little bit of a delay with the iPad, but I'm going to keep track of that. And if there's any questions at any point, just let me know either in the live chat feed or you can drop a comment below. So basically what I was just saying, because the absolute value of a negative number is the positive version of that number, just like when we square a value, a positive value, or we square its negative counterpart, we get the same output. Negative 3 quantity squared is positive 9, positive 3 quantity squared is positive 9. In the same way, when we do the opposite operation of rooting, when we solve the equation that has an exponent of 2, we're going to have to consider the positive and the negative results. The same thing is true for absolute value functions, but instead of taking the square root to do the opposite of squaring, now we're just going to be removing the absolute value bars that already exist in the equation. But in order to do that, that requires the process of considering both the negative and the positive outputs. So for example, let's look at this equation. So we have 3 times the absolute value of x plus 5 is equal to 21. So the first thing I'm going to want to do is to get everything that's inside the absolute value bars by itself, or as close to being isolated as possible. So I'm going to first divide by 3 on both sides. And so I'm going to get the absolute value of x plus 5 is equal to 7. 21 divided by 3 is 7. And I'm so sorry, my iPad is being very slow, so let me just disconnect it real quick and reconnect it. It is being really, really slow today. I do apologize. Just give me 1 second. Okay, let's try that. So now that we have the absolute value of x plus 5 is equal to 7, we're going to remove the absolute value bars. But in order to do that, that's better. Yeah, it's not as slow as it was before. It had a huge delay. So in order to do this, we need to split this into two separate functions. One in which we're going to consider the positive result, the other in which we're going to consider the negative result. So the positive result is just the equation without the absolute value bars. So we're going to have x plus 5 is equal to 7. The other equation, we're going to negate the output. So we're going to still have x plus 5, but instead of positive 7, we're going to set it equal to negative 7. Now in order to solve, I'm going to subtract away 5 on both sides. So x is equal to 7 minus 5 is 2. Over here, x is going to be equal to negative 7 minus 5. That's the same thing as negative 7 plus a negative 5, which is going to be a negative 12. So there are two answers to this absolute value function. Either x is equal to 2 or x is equal to negative 12. If you have any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. Please look at question number 1. Question number 1 reads 4 times the quantity, 4 times the absolute value of x minus 2 is equal to 32. So I'll keep track of the time in the upper right-hand corner, and I'll update it per minute. Okay, looking at number 1, the first thing we want to do is to try and get the absolute value by itself. So the 4 is multiplying into the absolute value. So I'm going to divide both sides by 4. That'll cancel the 4's on the left, and that'll leave me with the absolute value of x minus 2 is equal to 32 divided by 4. 32 divided by 4 is 8. Now, in order to remove the absolute value bars, I need to consider the positive and the negative results. So I need to split this into two separate equations. The positive version is going to be x minus 2 is equal to 8. The negative version is going to be x minus 2 is equal to negative 8. Adding 2 on both sides, I'm going to get x is equal to 10. And I'm going to have x is equal to negative 6. If you have any questions at all, then please let me know. Otherwise, let's look at question number 2. Question number 2 says 5 times the absolute value of x plus 1 is equal to 35. So I'll give you 3 minutes, and then I'll give you the solution. Okay, so I need to get the absolute value by itself. So the first thing I'm going to do is divide the 5 away because the 5, oops, excuse me, the 5 is multiplying into the absolute value. So if I if I divide by 5, then that's going to cancel that leading 5 out in the numerator. And so I'm going to have the absolute value of x plus 1 is equal to 35 divided by 5 is 7. I need to split this into two separate equations, one considering the positive output, the other considering the negative. The positive is just literally removing the bars and rewriting the equation without them. The negative is you negate the output. So our output for the second equation is going to be negative 7. So we're going to have x plus 1 is equal to positive 7. And we're going to have x plus 1 is equal to negative 7. Subtracting 1 in both equations, we're going to have x is equal to positive 6 and x is equal to negative 8. If you have any questions, then please let me know. Otherwise, let's take a look at number 3. Number 3 says 10 times the absolute value of 20x is equal to 1,000. I'll give you 3 minutes. Okay, so the first thing we want to do is get the absolute value by itself. So I'm going to divide by 10 on both sides. That's going to cancel on the left-hand side. And we're going to have the absolute value of 20x is equal to 1,000 divided by 10 is 100. Now we need to split this equation into two separate considerations, one for the positive, the other for the negative. The positive version is going to be 20x is equal to 100. The negative version is going to be 20x is equal to negative 100. Dividing by 20 on both sides, we're going to find x is equal to positive 5 and x is equal to negative 5. If you have any questions, then please let me know. Otherwise, let's take a look at question number 4. Question 4 says 4 times the absolute value of 3x plus 3 is equal to 48. I'll give you 3 minutes and then we'll go through the solution. So for number 4, I'm going to divide by 4 to get the absolute value by itself. if I do it to the left-hand side, I have to do it to the right-hand side of the equation. So then I'm going to have the absolute value of 3x plus 3 is equal to 48 divided by 4 is 12. Now in order to remove the absolute value bars, I'm going to have to split this equation into a positive and negative consideration. So I'm going to have 3x plus 3 is equal to positive 12, and I'm going to have 3x plus 3 is equal to negative 12. Subtracting 3 on both sides, I'm going to have 3x is equal to 9. Dividing by 3, x is equal to positive 3. Or in the second equation, when I subtract 3, then I'm going to get 3x is equal to negative 12 minus 3 is a negative 15. And then dividing by 3, x is equal to negative 5. So x is either equal to positive 3 or negative 5. If you have any questions, then please let me know. Otherwise, let's look at number 5. Number 5 says 5 times the absolute value of 10x minus 5 is equal to 125. So I'm going to give you 3 minutes, then we'll go through the answer. Okay, so in order to get the absolute value by itself, first we need to divide by 5 on both sides. That'll eliminate the 5 on the left, leaving us with the absolute value of 10x minus 5 is equal to 125 divided by 5 is 25. So in order to remove the absolute value bars, I need to consider the positive and the negative outputs. So I'm going to have 10x minus 5 is equal to 25. And I'm going to have 10x minus 5 is equal to negative 25. Adding 5, I'm going to get 10x is equal to 30. And then dividing by 10, I'm going to get x is equal to 3. In the second equation, I'm going to add 5, and I'm going to get 10x is equal to negative 20. Dividing by 10, x is equal to negative 2. So your answers here are going to be x is equal to positive 3 or x is equal to negative 2. If you have any questions, then please let me know. Otherwise, let's take a look at question number 6. So question 6 says 4 times the absolute value of 2x plus 4 is equal to 64. So I'll give you 3 minutes and then we'll go through the solution. Okay, so dividing by 4 on both sides to get that absolute value by itself, that'll eliminate the 4 on the left, leaving us with the absolute value of 2x plus 4 is equal to 64 divided by 4 is 16. Now I need to split this equation into two separate equations. The positive is going to be 2x plus 4 is equal to positive 16. The negative is going to be 2x plus 4 is equal to negative 16. Subtracting 4 on both sides, we're going to get 2x is equal to 12. And we're going to get 2x is equal to negative 20. And then finally, dividing by 2, we're going to get x is equal to 6, and x is equal to negative 10. If you have any questions, then please let me know. If there aren't any other questions, I actually want to group the last two problems together, and these will be the last things that we do for today's session. So let me bring the question number 8 up here, and we're going to look at the two problems. 7 is 3 times the absolute value of negative 2x plus 3 is equal to 27. And 8 is negative 6 times the absolute value of negative 2x minus 10 is equal to negative 48. So I'm going to give you 3 minutes. Please look at these two problems. And actually, I'll give you 4 minutes because there's two problems. So I'll give you 4 minutes, and then we'll go through the solution, and that'll bring us up to the end of class today. Okay, so I started to, well, I didn't start, but I started and finished solving these two problems. So if we look at 7, we have 3 times the absolute value of negative 2x plus 3 is equal to 27. So first I divided by 3 on both sides. That gave me the absolute value of negative 2x plus 3 is equal to 9. 27 divided by 3 is 9. In order to remove those absolute value bars, I need to consider the positive and the negative output. So I split that equation into 2 separate equations. Negative 2x plus 3 is equal to positive 9, and negative 2x plus 3 is equal to negative 9. Then I could subtract 3 on both sides. So I got negative 2x is equal to 6, and negative 2x is equal to negative 12. Dividing by negative 2, I got x is equal to negative 3 and x is equal to positive 6 as answers to number 7. For number 8, we have negative 6 times the absolute value of negative 2x minus 10 is equal to negative 48. The first thing that I did was divide by negative 6 on both sides to get the absolute value function by itself. That left me with the absolute value of negative 2x minus 10 is equal to negative 48 divided by negative 6 is going to be a positive 8. Removing the absolute value bars gives me a positive and negative consideration of negative 2x minus 10 is equal to positive 8, and negative 2x minus 10 is equal to negative 8. Adding 10 on both sides gives me 2 equations of negative 2x is equal to 18 and negative 2x is equal to 2. Finally, dividing by negative 2 yields answers of x is equal to 18 divided by negative 2 is negative 9, and 2 divided by negative 2 is negative 1. So we have x is equal to negative 9 and x is equal to negative 1 as answers to number 8. If you have any questions on anything that we've done today, then please let me know. If you find these videos helpful, then please like the stream and subscribe to my channel. I'm here for you guys every Monday, Wednesday, and Friday. Tuesdays are the reading sessions, and Thursdays are the writing sessions. And Dr. Todd, are you going to say goodbye to everybody? Dr. Todd, you want a cookie? Say, not really, I'm very tired. Dr. Todd, come on, you got to say bye to everybody. Come on. Say, oh, if I have to. Oh, bye. Okay, very good. Thank you guys very much for signing in. I hope you have a wonderful weekend, and I'll talk to you all on Monday.